I am so glad to be in Sweden again. I was here 2 years ago, and I was talking about user interface animations. And now I'm going to be talking to you about the future of user interfaces, because Isa was right. It's not about just the tools, but it's about the community and what we enable and build for our users. So I want to talk about how we could actually enable our UIs to sort of read the minds of users and to enable better features and more enhanced workflows for everyone, regardless of capability or where they come from or anything like that. So just to give you an example of the UIs that we have today, we look at it in a very simple way. For example, we might have a button where you click, it fetches data, we wait for the data to come, and then it eventually comes. However, users, we need to consider the way that they behave with our UI. So, for instance, me, I get a little bit impatient when it takes a long time to load. So I might have a loading spinner that sort of shows we're in the process of getting your data, and eventually it comes back. Now, this might be fine for most use cases, but especially if the user is me, I get really impatient. And so I will click that button many times, thinking that for some reason the data will come back faster. It never does. But you're a web developer, or a lot of you are. And so you think, I'm smart. I will disable the button. And that way, I can't click it too many times. But I'm also a web developer, and I could go into DevTools, undisable that button, and make as many requests as I want. The point is that everyone is different, and the way that we behave with user interfaces might not be the same amongst all of us. And that's why, in my view, A/B tests are sort of ineffective, because if we don't have A/B tests, then we're shoehorning all of our users into using the UI in one specific way. But with A/B tests, now they're choosing between two ways, each one of which might not be the most optimal way that you could present the UI to the user. So in short, one size doesn't fit all. And we can't look at our user flows as just linear path of we assume that they're going to log in, go to the dashboard, execute a task, and do something else. In reality, our user interfaces are a lot more complex than that. This was actually inspired by me walking around IKEA. So there are tools that exist for this, such as Guest.js. And Guest.js uses predictive analytics to prefetch web pages in real time as users use them. And it uses Google Analytics to just to measure which page is a user going to visit, depending on which page they're on first. And based on this, it could provide a more streamlined user experience by loading the page ahead of time for the user. So this is an example of what we call an adaptive user interface, also known as AUI. Now, some of you might have heard the term responsive user interfaces, and you might think, all right, adaptive sort of sounds like responsive. But there's a main difference, and that's that responsive user interfaces adapt to the content size. So the size of your device, or like if you're using an Apple Watch or a phone, or maybe if you're using your computer in portrait or landscape. I don't know if you could turn your laptop around, but it's usually landscape. Anyway, so it responds to users and not to devices. So think of a responsive design where it's based on how we behave and how we are as an individual. One of the earliest forms of an adaptive user interface, you might remember, is Clippy. And we also have things such as Cortana, Alexa, and Google Home as well. That it's just personalized based on the way that you are. So the way adaptive user interfaces work is we have this mapping in our application of where users can go and what they can do. And so based on this, we collect analytics over time and determine what are the most likely paths for the user. So we could see use cases of these adaptive user interfaces in things such as this flow where you have a delete button. You could either confirm or say, I don't want to delete it. But this is 2 steps for the user. If we are able to predict that the user is always going to confirm, or most of the time confirm that they wanted something deleted, then we could shortcut this instead and say, instead, just delete it and just give them the option to undo. And so it's sort of the best of both worlds. We make it easier for the user, but we also provide them a way to choose the alternative option. One example of an adaptive user interface, too, is using Gmail. I don't know if you've noticed, but it actually predicts what you're going to say next. And I've used this so many times, so if you see me using the same responses in my emails, it's probably because I'm just doing this and I'm letting Gmail complete it for me. And also texting with Google, it does it the same way. I work for Microsoft, not Google, so I don't know why I'm talking about Google so much. Please don't tell Microsoft. Also, adaptive user interfaces make it more streamlined for experienced users to use the app in a way that they find more efficient. So power users, whereas other users might need more help, and adaptive user interfaces can recognize those users and be able to provide them assistive steps. However, developing these adaptive user interfaces is challenging. It's not so easy to know which parts should we make adaptive, which parts should we hide and show, how much control should we give to the user versus automatically adapting the user interfaces to fit their needs. And I have a solution for this, and it's a solution that has been around for a few decades. It's this idea called model-driven development. And so what is model-driven development exactly? It starts with realizing that our applications are really these user flows of we have certain states that our app can be in and certain ways that users can transition between these states, much like this user flow diagram. More formally, this is known as a finite state machine, which is a mathematical model that models states and transitions together. Just a summary of a finite state machine, it's 5 different parts. We have an initial state, and that's a state that you start your app in or your system or project or whatever. And it's the very first state that the user is going to see. We also have a finite number of states, and these are all of the other possible enumerated states that the app might end up in. We also have a series of events that can happen through the app that transition between each one of these states. And we could also denote some states as final states, meaning that the flow is done and we can no longer transition from these states, such as when a user signs out from the application. So there's many different ways to actually create these finite state machines. The traditional one is by using a switch case statement. It's a little bit verbose, but it is the way that, if you want to use it between languages, this is going to be your most common way. So in short, a switch case statement, we could say which state we're in, such as the searching state. We could figure out which events just happened, such as the resolve event. And then from there, we determine what the next state is going to be, such as the success state. However, I like to use object mapping just because it's a little bit more concise, although it requires a tiny bit more code to actually navigate through this object. So it's sort of the same way as a switch statement. We have our states in an object, and then we have this mapping of states to other states based on events. And then so we just determine which event just happened, look it up on the object, and if that state doesn't handle that event, then we just default to that same state. I created a library called xstates that makes this process a little bit easier and also deals with hierarchical states, parallel states, and other state chart features, as I'll talk about soon. But it's essentially the same format. You pass that object into a machine, and then you do the exact same thing. You have a state, it looks at which event occurs, and it tells you what the next state is. You could use xstate with React, where you just pull it in and then you use it as a hook. I know many of you are using React, but you might be using Angular, Svelte, Vue. Xstate also works with all of these things, but I do want to mention that you do not need a library to do anything that we're talking about in this talk. It's just the general idea of using state machines and state charts to model our user interfaces. So state charts, real quick, it enables a few more things, such as actions, guards, which allow you to prevents certain transitions from happening. It allows you to nest states together to make orthogonal regions and to provide history states, which not something I'm going to go into in this talk, but I will provide resources at the end. Now, state charts were invented by a computer scientist by the name of David Harrell in 1987 in order to simplify the combinatorial explosion of states that he saw happening with typical finite state machines. So one way that hierarchical states simplify is by grouping similar behavior together. For instance, in this state machine, we know that in the success or failure state, when we search, we go back to the searching state. And so this could be represented by nesting these states right into the search state, this sort of parent state, and defining common behavior for both of those states. And then we could define that on the search event, regardless of which child state we're in, we transition back to searching. So let's take a practical example. Let's say that I have a feedback form where I ask, how was your experience? You could just imagine this sort of popping up in your app. You say it was good or bad. And if it was bad, I want to know about it. So you tell me about it, and then you press submit. And whether you press good or bad, it says thank you. So just in short, the way this works, using the same sort of finite state machine approach, we could say good, we could say bad, and fill out the form. No. And yeah. So how can we make this type of user interface adaptive? So what we could do is first create an abstract model, which we did, this finite state machine representation of our app. We could use analytics based on the transitions to determine which paths can be potentially adaptive. And then we could use analysis to enable this adaptation in our app in real time. So there's a few tools that we need to make this happen. One is weighted graphs. And a weighted graph, if you know what a directed graph is, if you don't, then talk to Vaida Hijashi, who does base CS, because she has amazing articles written on all these topics. So a weighted graph is basically a way of saying the user is more likely to go from this state to this other state than this state right here. So for example, we see that 90% of the time, we transition from signing in to success rather than to error. Now, the realization is that our user interfaces, all paths are not created equal. The user might prefer using a certain path in a certain flow throughout the app more often than they take the other paths. So I did this in Visual Studio Live Share, where we were modeling the user interface inside of VS Code itself. And so if we have a state machine, and we were determining like how many users joined, how many users were creating sessions, how many users were joining sessions, then we could automatically feed this data into a D3 diagram and visualize what are the most common paths for users to take. So let's do this in real time with this application. Let's say that, for example, I want to know whether we should show the form or not. And so right now, we just have an empty form. So let's say that the user clicks bad because they're having a bad experience. And let's say that they see this form and they don't really want to fill it out. What we could do is we could track those analytics and track that from the question state, they clicked bad, but from the form state, they just closed it out. And so we have this close right here. And then let's say that the user continues to have a bad experience, but is just completely alienating this, this feedback form. And so we could see when we click bad, escape. All right, so right now, we see that the user has clicked close on the form and didn't really complete the form. So what could we do instead? We could measure that and say that once it reaches past a certain threshold, when they click bad, now realize none of the code has changed, it takes you directly to the thank you screen and instead provides you a button to provide feedback. And then you could click it, go back to the form screen, and then we could see that if the user keeps doing that, that eventually it will show the form by default again. So that's one example of an adaptive user interface. So there's many ways that we could do this sort of analysis. We could analyze based on transitions. Take this sample Instagram app, for instance. You know when you go onto Instagram, it takes you to this profile screen first, or maybe a gallery, or maybe your camera. What we could do is we could determine which path is most likely for the user to take. In this case, it's the camera. And so we could use those analytics, feed it back directly into the app, and determine that we should probably open the camera first when the user opens Instagram. We could also analyze based on events and sort of give scores to what we want the user to do and optimize for that behavior. For example, if we want the user to click an ad, and please don't use this for ads, I'm just saying this as an example. But let's say that if ads are interspersed, if they scroll, we want to assign a negative score because that's not the behavior we're trying to encourage. But if they do click on an ad, then we assign a positive score. And so we could say that depending on whether ads are interspersed or shown on top, which one they respond to more and which ones are more likely to click, we could determine which kind of ad showing we want to show, interspersed or shown at the top. So we could use decision trees to help us too, because there's a whole ton of parameters that go into making these sort of decisions, and decision trees help with that. Decision trees are a visual model for, well, making decisions. It's a statistical model too, so we could say that based on user information like how new they are or how many friends they are, we could say that we should either show an ad at the top or we should show less ads because they're more likely to click an ad if it's not too common. And so we could make determinations based on that. So shortest paths can also help us with prediction because we can't just look at each path in isolation. Instead, we could use weights to help us determine which paths the user is more likely to take. For instance, or actually, well, in XState, you could have in the onTransition method, you could track how the states are going to transition, and you could determine the target, the source, the event, and the timestamp, and feed all of that information into analytics, whether you're using Google Analytics, Kissmetrics, Segment.io, things like that. So based on those weights, we could determine what the shortest paths are, and those paths might not be what you expect. For instance, given these measurements, we see that the shortest path from A to C is actually ADEC and not ABC. But these shortest paths aren't, the weights for the shortest path need to be determined in sort of a broader scope. For example, let's say that we're going from state A to state B or C, and we determine that it's more common for the user to go from A to B. This might not tell the full story because depending on which state the user came from, it might be more likely that they might travel to a different state. So these are just things that you should research and keep in mind. And we could also use deep learning and reinforcement learning to further assist predicting what the user is going to do. For instance, we could see that the path traveled by the user over here is the actual path, and we could have some sort of reinforcement learning agent try to model what the user is going to do and assign positive rewards or negative rewards based on whether it made the correct prediction or not. And then over time, it will predict correctly what the user is going to do. So we could now use more simulation rather than getting actual user feedback. And so we could feed this into this reinforcement loop and improve our analytics over time in order to create adaptive user interfaces that learn from the users based on data that's fed into Google Analytics, Mixpanel, Kissmetrics, Segment.io. And this could be done in real time as well. So this is all based on the idea that we're using software modeling to help not only develop our apps, but also to improve the user experience in real time. And software modeling has a lot of these benefits, like visualization of these graphs, communication between designers, developers, and other stakeholders. It automatically can generate tests for us. It allows for simulation based on those machine learning and artificial intelligence models. And finally, it provides analytics that we could use in real time. So these adaptive user interfaces allow us to create personalized systems for users, prevent information overload in simplifying the actions that users do, provide intuitive guidance for users who might be new to the applications you're creating, and help the users understand the tasks and goals necessary for them to complete. There's a lot of considerations when thinking about adaptive user interfaces. For example, do we want to adapt on the component level or on the app-wide level? Do we want to adapt on routes, or do we want to adapt based on specific, smaller user flows? And then there's the idea of prediction versus feedback. Prediction is great because the user interface sort of works magically for the user, but feedback can also be a useful tool because the user doesn't want to be interacting with some magical black box. Instead, they might want to have control over how the app adapts to them. And then there's data versus simulation. Should we be collecting real data? Should we instead be simulating and basing it on previous data so that we protect the user's privacy? And things like that. So there's many advantages of using software modeling and state charts, and the example I'd like to point to most is the Mars rover by NASA, which, by the way, this was a $100 billion project. Imagine if you had one shot at deploying something to production, and if anything went wrong, you just wasted $100 billion for your company. I mean, this is something that you really don't want to do. Using state charts and software modeling, besides providing those analytics, it provided visual modeling and precise diagrams for even non-technical people to see what kind of logic and behavior this rover was going to have. It provided automatic code generation, which is just a safer approach, especially when you have millions of lines of code. It provided comprehensive test coverage, which meant that no matter what happened, they were able to predict any possible situation that this rover can be in. And also, late-breaking requirements and changes were automatically adapted in that, like when someone made a change or when someone requested a new feature or some changed behavior, they were able to see which parts of the model were going to change as a result. So the visualizer I made for XState consumes these types of abstract models, which you could make executable by adding into your application. And so these can be visualized directly just like this. I'm short on time, so you could just check that out later. The XState ecosystem, which I've created for software modeling and front-end applications, but also back-end applications and anything that uses JavaScript, is growing. I just released a testing library, and I'm going to soon be releasing an analytics library to help out with creating all of these analytics and adding adaptive user interfaces to your applications. So there's a lot of resources, such as the world of state charts, which is just a great explanation of how state charts are used in practice and all of the terms and things to learn. There's a Spectrum community, too, where we talk about this. And of course, I have documentation because you have to have documentation. So in short, I want to make your code do more. I want your code that you write to do more than just executing a task or accomplishing some sort of business requirements, but I want your code to actually understand what the user's individual needs are and be able to adapt user interfaces, automatically generate tests, be able to be visualized, and so much more. I have 1 minute left, but I wish I went over time because they said a bubble machine would turn on. So anyway, thank you, Nordic.js.